Hello students. So today we are going to learn about functions. Okay. So what is a function? So function is a relation. Okay. It is a relation from A to B and we write it as f from A to B. Okay. And it is said to be a function if every element of set A has one and only one image in set B. Okay. So every element of set A okay, every element of set A has one and only one image like this. Okay. Only one image, not two images. So if you have a element okay in A which has two images, say this element has two images, this one and this one. So this now is not a function. Okay, it's not a function. If you get a diagram like this, then this is not a function. Okay. So only one image should be there. But elements like, for example, if I take 1, 2, 3, A, B, C. Okay. 1 is going to A, 2 is going to B, and 3 is also going to B. Okay. This is a function. Okay. The elements in A can be mapped to a single element in B. But the elements in A, one element in A cannot be mapped to two different elements in B. Okay, this is not a function. This becomes a function. Okay. So, and it is denoted by if f is from A to B, then the function is written as f of A is equal to B. Okay, where A belongs to A and B belongs to B. Okay. Let's see some examples. Let n be the set of natural numbers and the relation R defined on n such that R is defined. That is a set of this relation is defined as x comma y such that y is equal to 2x. Okay, where x and y belongs to set of natural numbers. Okay. Now we have to check whether it is a function or not. First we'll write the elements in the relation set. Okay. So natural numbers start from 1. So if you put here 1, your y will be 2. So 1 comma 2, 2 comma 3, 3 comma 4, 4 comma 5 and so on. Okay. As a natural number set of natural numbers is an infinite set, this is also an infinite set. Now let's draw this. Okay. So here 1, 2, 3, 4 and so on. So 1 is mapped to 2, 2 is mapped to 3 like this. Okay. This one remains. Okay. So every element in set A is mapped to a element in set B. And every element in set A has a different image. So unique image in set B. Right? So this is a function. Okay? Its domain set is this whole set. One, two, three, four, and so on. Then codomain is again the whole set. You can write this as set of natural numbers. Codomain is also set of natural numbers, but range set starts from 2, 2, 3, 4, 5. 1 is not there. Okay, so this is a function. Let's solve some examples. Examine each of the following relations given below and state in each case giving reasons whether it is a function or not. Okay, so relation is given 2, 1, 3, 1, 4, 2. Okay, so if you draw this first set, it is 2, 3, 4, and here 1 and 2 are there. 2 is going to 1, 3 is going to 1, and 4 is going to 2. Okay, this is a function because each element has a different image. Okay, next, 2, 2, 2, 4, 3, 3, 4, 4. Okay, so if I take 2, 3, 4, 2, 3, 4. So 2 is going to 2, 2 is going to 4, 3 is going to 3, and 4 is going to 4. Now this is not a function because 2 has an image 2 and also it has an image 4. Okay, so this is not a function. Okay, there is one more definition. A function which has either R means real number, set of real numbers, or one of its subsets as its range is called a real valued function. Okay, further, if its domain is also either R, real numbers, or a subset of R, it is called a real function. And then they have given one example, that is a function is defined from set of natural numbers to natural numbers. F of x is equal to 2x plus 1. Okay, and you have to just substitute the value of x. So if I put here 1, you'll get f of 1 3, f of 2 5. Okay, like this you'll get. So the set of domain is natural number. Okay, domain is your set of natural numbers which is a subset of real numbers, and codomain, not codomain, range is from 3, 5, 7 and so on, like this, which is a subset of R again. Okay, so this is a real value function. Now we'll see some types of functions. Okay, some functions and their graphs. So here the first function is our identity function. Okay, identity function I'll write here. Okay, identity function, it is defined from real numbers to real numbers. Okay, where y is equal to f of x or f of x is equal to y for each x belonging to R. Okay, and this is f of x is your x, means whatever number is here you will get number, the same number here. That's why it is identity function. It is mapping onto the same number. So we'll just draw the table. Okay, like we used to draw for 10th standard drawing graphs. Okay, x and f of x. If I take 1, I'll get 1, 0, 0, -1, -1, minus 1.5 minus 1.5, then 4, 4. So you have to draw this on a graph. Okay. 0, 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, minus 1, minus 2, minus 3, 1, 2, 3. Okay. So for 1, we'll get 1, 0, minus 1, 1.5, you'll get 1.5. Then for 4, you'll get 4. So you'll get a straight line which passes through the origin. Okay. Now you have to write what is domain, what is range. Okay. So domain here is set of all real numbers, right? And range is also, because we are getting the same thing, is set of all real numbers. Okay. Next function, drawn all the functions. Okay. Second function is your polynomial function. I'll just write. Function is from real numbers to real numbers. Okay. And polynomial are in the form x square, x cubed. Okay. So one more is remaining constant function. Okay. We'll do it later. So polynomial function, in terms of means in general also you can write, that is y is equal to f of x. This is just an example of polynomial function. A0 plus a1x plus a2x square plus dot 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 an x raised to n. Okay. So if I draw the table for this, I'll get, for 1 square you'll get 1, for 2 you'll get 4, for minus 1 you'll get 1, for minus 2 you'll get 4. So you can observe here that the range has only the positive elements, positive numbers. Okay. And the graph, okay, for 0 you are getting 0, for 1 it is 1, for minus 1 you are getting minus 1, 1, 2 you are getting 4, minus 2 you are getting 4. So like this you'll get. Okay. So your domain, it is a set of all real numbers, and range is a set of only the positive numbers, okay, including 0. So it start from 0 to infinity, set of all positive real numbers. Okay, let's write constant function. Constant function, again f from r to r, and it is defined as f of x equal to c. Okay, where c is some constant. Now for example, if I take f of x is equal to 2, Means whatever number you take here, you will get 2 as the y. Okay, so if I draw the f of x, so for 1 I'll get 2, for 2 2, minus 1 2, 0 2, minus 2 2. Okay, so whatever it is, we'll get 2 as y. So if I draw this for 1, for 1 we will get 2, for 0 2, 1 2 2. So we'll get a line which is parallel to x-axis. Okay, so here domain is the set of all real numbers and range is only the singleton set, which is 2, because all elements are mapped to only one element, that is 2. Okay. Next function is our on the textbook it is given x cube. Okay, so same way you have to draw for x square. It was like this. So for x cube, it is like this. That is, you will get negative numbers also, because minus 1 cube is minus 1, minus 2 cube is minus 8. So you will get positive as well as negative numbers. Okay. Then we have rational functions. For rational functions, you can take for a rational function f from R to R, but here you have to define your domain. That is, if you are taking f of x equal to 1 by x, x should not be 0. If it is 0, then it is not defined, right? So you have to remove 0 from this. Okay. So now you can take all the elements except 0. Okay. And you will get a same way you have to draw the graph, and you will get graph like this. Okay, for 1 by x. So it is not 0, but it is going towards 0 like this. So it will be 1 by 2, 1 by 3, 1 by 4. So it is close to 0 but not 0. Okay, both negative and positive. Yes. Range is also domain is r difference 0, and also range is r difference 0.